So tell me about fructose. So, it was interesting. I came to work and all of a sudden I started getting insecure because I knew I was preparing for this conversation, and I put my, organic Earl Grey and my organic cane sugar, 4 teaspoons. I thought, now I'm going to get yelled
Four
at.
teaspoons.
4 teaspoons because it lasts all
Okay.
day. It's like 40 ounces, it's instead of
Okay.
cookies and cakes. And I started to think, well, what is corn? What is, it's been a while. What is just regular cane sugar? And it's organic, which is what I tout because of those less chemicals, less endocrine disruptors. I really promote cleaner food, but it's sucrose is glucose plus fructose.
Right.
And then now tell us about fructose and how much is that component of sucrose a
Right.
problem for everybody but me, particularly with my tea? And is there a way to get a sweetener eventually without the fructose, which is really one of the bad guys here?
Right. So the bottom line is that all caloric sweeteners are sweetened with fructose. Molasses is only glucose.
Molasses is
But
only interesting.
But molasses is not that sweet. I mean, you don't see people going around chugging molasses, do you?
No, but also molasses has acrylamide and some of these chemicals that offset.
Sure.
People think, great, I'm going to do that now, but then you think, oh, there's some other issues there.
Of course. But the bottom line is molasses is devoid of the addictive substance. Okay. So molasses is not a big seller. Yeah, it might be okay in a cookie, but only because you put the sugar in too. So the bottom line is that there are these two molecules, and the food industry equates them. It says these are the same. A calorie is a calorie, a sugar is a sugar. Now, if you believe that a calorie is a calorie, then what you're saying is that the problem is calories in, calories out, because calories are fungible. Therefore, if calories are the same, then it's, too many calories in, too few calories out. Energy balance, that's their term. Every, CPG company, calls this energy balance. Okay, and if that's the case, then it's two behaviors, gluttony and sloth. Therefore, if you're fat, it's your fault. Therefore, diet and exercise. Therefore, any calorie can be part of a balanced diet. Therefore, don't pick on our calories, go pick on somebody else's calories. So all of those mantras that I just listed are dependent on this notion that calories are fungible, that every calorie is like every other calorie. Okay. And if a sugar were a sugar, and if glucose were fructose, then they would be right. But it's not. And we have the biochemistry, and we've had the biochemistry for 50 years to show that this is not the case. We've actually had it since 1967 to show that this is not the case. And I learned it in college, that it was not the case. But the food industry continues to say it, and the reason is because this is how they assuage their culpability. This is their shield. This is how they keep the FDA and the plaintiff's bar, from taking them down. Is with this notion. But it's completely false. And we have the data to show this. We have it every which way from Sunday. Okay, so let's talk about the two different sugars, glucose and fructose. Glucose is the energy of life. Every cell on the planet burns glucose for energy. Glucose is so goddamn important that if you don't consume it, your body makes it. You will remember from your Biochem 101, there's a process called gluconeogenesis. Right. And it will turn amino acids into glucose, and it will turn glycerol into glucose.
It's anthropology.
In the liver. It's anthropology. Okay. Animals who are, devoid of food, like polar bears, they have to be able to still generate a glucose level. And so they will turn fat into glucose in the liver. Ketotic hypoglycemia is when, that gluconeogenesis problem, issue in the liver is not fully mature in babies. And so they end up running out of glucose and their blood glucose drops and they have a seizure and they show up in our emergency room and I take care of them. So there's, loads of data to understand how important glucose is. However, having said that, glucose is not important to eat. It is important to have a blood glucose level, but it is not important to have a dietary glucose content. Not the same. And the reason is because you can make it. Okay, it's not essential to eat. It's essential to have, but it's not essential to eat. Okay. Big difference. Yeah. Now, fructose, on the other hand, this other sugar, the sweet sugar, the molecule we seek, is a whole different ballgame. So there is no biochemical reaction in any vertebrate on the planet that requires dietary fructose. It is completely vestigial to all animal life. It is a holdover from our plant ancestors. And it's why they're plants and not humans. Okay. They got stuck, in terms of evolution with fructose. And fructose is, it's an okay way to store energy, but it's not a great way. Okay. But what it did do was it got animals to like that molecule. And so they would eat the fruit and therefore scatter their seeds. So it was their evolutionary construct to propagating their species.
Right. There has to be a reason to be eating it so that, they could keep going with their genetic offspring, the seeds, the plants, the fruit. Yes.
Right. The problem is that when you consume a large fructose load, like a 20-ounce Coca-Cola, it's going straight to the liver. The rest of the body cannot utilize it for energy. It goes straight to the liver, and the liver becomes overwhelmed. The mitochondria, the little energy burning factories inside each of our cells, can't handle the onslaught. And in order to deal with it, it turns that excess into liver fat. And that's where the fatty liver comes from. And that's why 45% of Americans today have fatty liver when they never did before.
It doesn't raise insulin, though, but it goes to fat.
Yes, it does.
Oh, it does raise fructose, does raise insulin.
So it does it in two ways. Number one, if your liver's not working right because you have fatty liver, your pancreas has to make more insulin to tell the liver to do its job. That's one. And it turns out that if you overwhelm your liver has what's called hepatic first pass extraction. And so it will, the fructose is coming from the gut via the portal vein to the liver. The liver is going to try to extract as much as it can on that first pass. And it's pretty good. It does about an 85% extraction. Which means that you're not going to get a serum fructose level. Unless you overload it. And if you overload it, you will generate a serum fructose level. And you will be able to measure it in the peripheral blood. So now the fructose is circulating in the bloodstream on the arterial side, and that will then go to the pancreas. And it turns out there is a fructose receptor in the beta cell. And when that fructose hits that beta cell, the beta cell goes hog wild and secretes a lot of insulin, because that fructose signal is telling the beta cell is, oh my God, the liver's in trouble, make more insulin to try to deal with it. So there is this sort of emergency system in the beta cell to increase the insulin in response to seeing fructose, which shouldn't be there.
Right. And fructose, just to remind my listeners, because not all of them are academic or medical or whatever, basically it's component of what are the foods that have fructose that are really bad guys?
Well, all of them.
Well, high fructose corn syrup is something that people might recognize on a label and something they could really try to avoid. Certain fruits are higher in fructose than others.
Right. So the bottom line is that any caloric sweetener, and there are 5, there's sucrose, table sugar, cane sugar, beet sugar, the stuff you put in coffee, high fructose corn syrup, which only the industry uses. You can't buy that, at the store. Honey, maple syrup, and agave. Those are all basically 50% glucose, 50% fructose.
What about monk sugar or monk? Yeah.
Monk fruit. Monk fruit is a non-caloric sweetener.
Huh.
So it does not have calories. It binds to taste receptors, but it does not actually have calories.
But it's fructose and glucose.
No, it's not.
It's not. Okay.
It's not. Monk fruit is not either. It's neither glucose nor fructose. It doesn't have calories. It is a diet sweetener. Stevia is a diet sweetener. Erythritol is a diet sweetener. You know, there's a host. There are lots of synthetic diet sweeteners like aspartame and neotame and azosulfame K, and new ones coming out, allulose and tagatose and what have you. Everybody's looking for the diet sweetener that's going to solve the problem. The
next packet with a different color, which might be purple.
Yeah.
Which I did want to, by the way, unless you want to finish up on your points there, I kind of want to get into the recent study that I thought was excellent from Cell Biology, or it was from Cell. Maybe you can explain it. I thought it was fascinating, and you said it was basically a landmark study, which I think is a pretty strong statement.
Yep. So to just finish up what we were talking about, fructose goes to the liver, gets turned into fat, and that fat then gums up the works. And it is the insulin response to a sick liver that is driving all the chronic metabolic disease. It's also driving the obesity, because the insulin is causing whatever energy is in your bloodstream to go into fat cells for storage. So fructose is an obesogen because it causes obesity irrespective of its calories. If fructose was just calories, then it wouldn't be an obesogen.
Got it.
But because it causes this insulin resistance problem, it is an obesogen. And so we were talking about the compounds that are in the food that cause the problem. This, to me, is the biggest one.